Welcome to Inside Builder channel, Python experts, PyTorch enthusiasts, and my dear friends. Exploring PyTorch on Raspberry Pi, hands-on data manipulation for AI enthusiasts. This is part 5 of multi-part video series that I am creating to explore Torch module and its submodules. We had last video checked, got introduced to cat, stack, uh, and squeeze functions. Also, we understood how to visualize and think about the batches of n-dimensional tensors. That is something that we started practicing, and we will continue in the loop and in that direction of further working on datasets. Now we are going to work a little bit on masking the tensors, the elements of the tensors, and then we will try to get the datasets from SKlearn and try to further work with cat and stack in this video. So this will be more like a exploration video. So you can just watch how the mask fill works, but rest of the things will be very similar to what we did in the last video. But it will be more like a practice session that you can try and you can see how it works for you. Let's move to the console. So I've already got the Raspberry Pi up and running, and we can actually check it's running at around some 48 to 49 degrees Celsius of temperature, and it's running cool right now. Let's move by importing Torch, and next I'm going to create a multi-dimensional tensor. That is, I'm going to create a 4x4 dimensional tensor. Let's begin the process. Torch.tensor, and I'm going to create a 4x4. So there will be 4 rows and 4 columns. So these are the rows that I have created, and I'm going to create the columns right now. The columns will be all these numbers. So this will be first four columns: 56, 87, 80, and 57 will be the second 4 columns. 68, 32, 46, 75 will be the third, and 57, 86, 98, and 62 will be the fourth. And I'm going to make the D type as tensor torch float 32. Nice. So I'm going to execute that, and you can see that it is a 4x4 matrix. You can see that here. I'm going to zoom in a bit so you guys can see it a little bit better. Next, what we're going to do is we are trying to mask the this tensor. Basically, when I say mask, say for an example, I don't want these numbers that is above the diagonal. I don't want them. I just want them to be zeros. What I can do is I can use the triangle upper or triangle lower. What if instead of the numbers that is present here, what if I want these numbers to be something else? That is what we are going to do with masking. Let's first of all create another matrix which is a torch once. This is required because we are going to use this as the base matrix, which will convert it to mask. So you will see how this works in a couple of seconds. I'm going to create a torch once of dimension 4x4. So I'm going to say 4x4, and it creates the dimension, and this is the one 4x4 tensor that is filled with ones. Next, I'm going to mask these ones with zeros. So for that, I'm going to create the next tensor that is going to be on B. I'm going to call not on B. I'm going to call torch, and I'm going to call try upper. Once I do that, it will be asking me for the tensor, the input tensor. So I'm going to give it as B, and I'm not going to change anything else. So after that, if I input C, you will see that the upper tensors are all retained and the lower tensor have become 0. So I have to mask the upper tensors, right? And the lower tensors, I want to leave it alone. So what I can do is right now, I'm going to use this. This is the mask. C is the mask right now, and I'm going to use this C to play with A. So I'm going to say A masked fill. So once I press tab after I say masked fill, it will, after I type mask, it will complete the autocomplete with masked fill. And inside this, you will see two things. It will ask for the mask, and it will ask for the value. The mask has to be the condition that we are going to provide, and this condition should include the tensor that we are going to use. So I'm going to use the C tensor, and I'm going to change the values wherever there is 0. So I'm going to change that value. So instead of attempting to change the upper numbers, I'm going to attempt to change the lower numbers. So I'm going to say C equal to 0, and in those locations, I want the number 125. This is what I want, and this new tensor I want to be assigned to the variable D. Once you execute this, you'll see that all the values below is changed to 125, and the above is left as it is. This is what we are talking about as masked fill. So you can play with this. You can also work with various other tensors also. It's not that you have to work with try u and ones, etc. You can use the regular tensors, and you can have various kinds of conditions here. This is an example that I have shown to you. You can execute the same example with a different, say if I say not equal to 0, then the things will be completely different. So if I execute this, I'm not going to assign it. If I execute this, you'll see all the values that was not 0. So all the values that were not 0, all become 125, and the rest of the values have been left intact. So like this, you can understand logic, and you can implement those logic inside the tensor. This is a small 4x4 tensor that I discussed with you. So this is one of the starting important function that I wanted to discuss. And then what we are going to do is we are going to move into pulling the data from datasets, and we are going to start working with it. Because before we start going into creating layers and starting to create with embedding layer and linear layer, dropout, etc., we need to have some good base with the data loaders as well as datasets. and how to work with them. So let us move to the console, and I'm going to import from SKlearn. I'm going to import datasets. This datasets module has a lot of methods that can create dummy data. You'll be seeing it in a couple of minutes. So what I'm going to do is I'm going to say dummy 01. So this is the first dummy data that I'm going to create, and I'm going to create datasets of regression data. I'm going to say datasets, and I'm going to say make. And once I say MA and press tab, you'll see there are various datasets that you can create. I would request that you guys start working with all these datasets one by one, but that's going to be quite a tedious activity. First, I would suggest to start with the regression and then move to working with classification, because this data is easy to visualize, and also it is easy to use it in the next step. Like you can actually use it in classification model or regression model, and you can start working with it. Rest of the data, you can try to get the data and try to do the plotting of this data and see how the data is actually created, the structure of the data. That's what I'm asking you to take a look. So I'm going to create regression right now, and once I call this particular function in datasets module, you'll see that it is asking me for lots of arguments. So I'm going to work with the number of samples, number of features, the number of targets, noise, and random state. Only these arguments. Rest of the things you can leave it as it is the default. We don't need to touch it right now. That's sufficient for us. So I'm going to say, in order to make the life easier, all you need to do is just copy this like this, and you can just paste it. You can just paste it. It will not execute because this particular star mark will not allow it to execute. So now let us proceed by creating the dummy data. So we know that in sample, in case of if you are going to use if you are having a better Raspberry Pi with higher RAM, then probably you will use VS Code. There we don't need to copy this. VS Code itself will provide the autocomplete options. So features, I'm going to take 3 features. Usually one is suggested because it becomes easy to plot it, but I am interested in looking at the higher dimensional data and to see how we can stack and how we can play with the data and push it into the models. So that's my interest. So in target, let us keep the targets as 1. So we don't need to have more targets at this moment. We can take just 1 target. If you're going to have classification, then you might need more targets, but here we are going to go with just 1 target. Noise is going to be, let us take 25, and noise can be any value. It's like a random value that you have to give. Random state is important. So if you're going to use the same settings that I'm providing here, you will get the same set of matrix values or the tensor values. And the output that you're going to get from this datasets is going to be NumPy NDArray. It's not going to be tensors. We have to convert it into tensors. Okay, now let us execute this, and it will execute it, and it will create it will pull the data. And if you try to execute, if you try to print the dummy 01, you will see that it's an array of 2 data. It's a tuple of 2 arrays, and the first is the x value, and the next is the target value. So what you have to do is you have to say x data and y data is equal to dummy 01. So what will happen is the data will get assigned to x data and y data, and after that you can take the shape of the x data, and you will see that it's 100,3 because there is 100 samples and 3 features. And if you look at the shape of y data, you'll see the shape is 100 cross 1, and it will not be 1 because it's not a column, right? It's still not a column. So this is something that I want you to understand. So if I say print, I don't need to print here. If I say y data, you'll see it's a single array, right? And it's a single dimension array, as you can see here. It's not multi-dimension. But if you look at the x value, so let me print the x data also. This is one of the easiest way to get tripped. If you're new to machine learning, it's very easy to get tripped with this particular step. So this is one data point, and you can see that it is covered with the open and close bracket, and beyond that there is one more bracket. So this is the entire data set from here to here. So 100 points will be there, 100 data points will be there, and it is all contained inside this particular square bracket. We have to convert the y into similar kind of columns. So it should have 100 rows and 1 column. So now it doesn't have any columns, so we need to convert that. As of now, in the NDArray, you don't need to convert it. We can actually convert it once we convert it into tensors by using views. So next step is to convert the data into tensor. So we will create a variable called as xtensor, and we are going to call torch.fromNumpy, and next we are going to send the NumPy data, that is x data, as type. We are going to use the type of float. That's very, very important, float 32, and then we are going to convert it into NumPy. We are going to convert it into torch tensor. That is going to take care of it, and same way we are going to do it for, okay, so NumPy is not defined because I have not imported it, so I'm going to say from, okay, import NumPy as NP. That should import NumPy, and I can execute this. Now it has executed. Next I'm going to call yTensor. I'm not going to change any of the shape of the tensor as I already told, of the NDArray as I already told. I'm going to just call from NumPy. I'm going to say y data, and as type So the as type is required here because we need float 32 in when we are going to process the tensors later. So that's why I'm making this as a habit right now. And you can now think about changing the y tensor to the column row tensor. So for that, what you have to do is you have to we can actually take a look at how we can change the view here itself and see how the output looks. So I'm going to say I'm going to need a couple of rows. We don't know how many rows, but we need one column for sure. So once I do this change, you'll see that now the same y data has been converted into a proper multi-dimensional, that is two-dimensional tensor. So if I say y tensor is equal to y tensor, and if I say view -1, 1, you can actually use the shape command and you can get the number of rows, and then you can mention the rows here. That is also one way, but -1 is much more comfortable. And you can take a look at the y tensor shape or size will be much better. And you'll see that the tensor size has been modified to 100 for one column. So this is what we need when you're going to send it into the model, and you're going to create when you're going to train the model. Anyway, so training the model is the next step, but before that we need to also try to work with concatenation and also with stacking. So here, if you take a look at the tensor x tensor, and if you take a look at the size, you will see it is having 100 rows and 3 features. So what if I want to break this into batches? So we have to first of all create batches of say, let us say 10. So we want to create 10 batches of 10 cross 3 tensors. So how will you do it? The first thing that comes to our mind is to use the x tensor view. So we have already seen that we can use view there, and will that work if we are going to give -1? So we are going to create 10 batches, right? And we want 10 rows and 3 columns. So we are not going to change this. And can this create the tensor? So you see that it has actually created the batches. So as simple as that. Now we have actually converted the x tensor into a batch of 10 cross 3 datasets. So I will actually make x batches, and I'm going to create this. And if I'm going to look at the first batch, so if I say I want to look at the first batch, you'll see this is the first batch. And now you can actually send this batch of data into the model and you can train it. So the 100 data points has been sliced into 10 data points, and you can start manipulating the model. Further, if you're going to still change it, you can play with it. The point here is that this is a kind of unstacking process. So you are actually using the view to, we don't know how many batches it can create, because here we know there is 100 rows, so we are telling this. But what if there are a couple of other rows that we don't know, or we have not checked the shape? So that would be hundreds of reasons. So that time -1 will be the best bet. And the same way, you have to convert the batch y also into batches. So for that, you have to use y tensor, and we are going to use the view function. We are going to say -1, and in case of rows, it will be 10, but the columns will be 1, because there is going to be only one target. And we are going to execute this, and you will see that the batches is also going to be having the shape of 10, 10, 1. So here it is, the x data is having x batches is having 10, 10, 3, because there are 3 columns. This is having 1 column. We have to keep on repeating these columns and rows until you become really comfortable with this. Next, what we are going to do is we can try to work with concatenation. But to work with concatenation, first of all, we need a couple of data points, right? So how are you going to get the data points? As simple as that, we are going to ask datasets. We already have the datasets with us. So we have already created we can import the data points from the datasets. So let us do this. So we are going to say new data, and we are going to call the datasets, and we are going to make again. This time we will try to stick with the existing make regression only. But if you guys are little more explorative, then you can try to go for classification, or you can try something like biclusters or various other types of data. But I'm going to stick with the 3 feature, and number of data points, I'm going to make it as 25. I'm not going to go beyond that, and I'm going to keep the noise as 25, and the random state I'm going to change it to 1, 2, 3, 4. And I think I'm missing the target, so I'm going to give the targets as 1. So that is the output. And next is I'm going to say x new, and y new is equal to new data. And after that, I'm going to convert the numpy array into numpy tensors. So I'm going to say new xt is equal to torch dot from numpy. That's going to be the x new. I'm going to take the x new dataset, and I'm going to convert it into tensor here. np dot float 32, and then next is I'm going to take new yt, and I'm going to say torch dot from numpy, and I'm going to convert that also y underscore new dot as type, and np dot float 32. So all these things will get converted into the new tensors, and I'm going to execute that, and you'll see that now we can concatenate these data sets with the x batches and y batches. So also you will face certain challenges there, and we are going to see how we can resolve it. That is the next couple of minutes our target. There was an error in there was a typo, so I'm going to correct the typo. and I'm going to re-execute it, and it got re-executed, and we have a new tensor available with us, new xt and new yt. Let us take a look at the new xt shape. We will see that it is 25 cross 3, and new yt shape will be just 25. So this is a single dimensional tensor. So we need to convert the new yt into multiple dimension, and that is n dimension. So for that we are going to use y and we have to say we need -1, 1. So that is, we don't know how many rows we are going to get, but we need for sure one column. That's what we are asking. And after we do that, we are going to check the yt shape, and it would have got converted to 25, 1. So that is how the things are moving right now. Now our intention is to concat the new yt with the existing y batches. So we are going to concat y batch. We are going to take only one batch. So this is one batch that you are going to take, and we are going to concatenate this new yt with this batch. So will this happen? First of all, let us try. So what we are going to do is, let me also show you the new yt so that you guys can see what is the data. So new yt is like this, and the batch is also pretty similar. It looks both are of same dimension. So concatenation should be pretty straightforward. And my expectation is that it will be concatenated into, instead of 25, 1, after the concatenation, it will be 35, 1 shape. So that is my expectation. So let us proceed. So expecting the shape of a new tensor will be 35, 1. So that will be 35 rows and 1 column. So let us continue with that. So we are going to say yb_yt. So that is the tensor name. So y batches and y tensor. So that's how I am creating the names. It's pretty simple. Try to keep a consistent format of names, because once your brain has a formula that what kind of names each of the variables are having, it will be pretty simple to follow on what is going on. Or else what will happen is you will actually miss the flow even in your own coding. Variable names are one of the key aspects. In fact, you have to practice to create variable names, and having creative variable names is not going to cut it. But having a long variable names are okay. So instead of saying yb, you can say y batch with new yt. So this is fine. It is absolutely okay to have longer long name like this. If it is okay for you to type, go ahead and do this. Never try to reduce typing, because that is one of the easiest way to get lost in the coding flow. So I'm going to use this y batch with new yt, and I'm going to use torch.cat, and I'm going to check what is required. So tensors are required. I'm going to give two tensors. One is the new yt, and the other is the yt batches. So y batches, and I'm going to give only one batch. I'm not going to give the entire batch, because the entire batch has a different dimension. It's not the same dimension as new yt, right? So that will not concatenate for sure. But let us see first whether we can concatenate this. And I'm going to execute this, and it concatenated. And let us see what is the shape of it, so size of it. As I told you, always use size, and you'll see that it is 35, 1. So next, what we can do is we can actually do the similar kind of things with x batch, right? So we are going to expect 35, 3 when we are going to concatenate x batch with xt, new xt, right? So we are going to do stacking also. So stay tuned for that. New xt and x batch, and that is also going to give me x batch size. So let me see the size then and there, and you'll see that it is going to give me 35, 3 rows. So now we have actually moved one step further. But what if I try to stack it? So what will happen if I do a stack? If I do a stack, what will happen is both the dimensions of a new yt and the yt batches will be maintained as it is, and these two will become a separate batch. So it will become 2 cross 2 different tensors. So whether it will work, let us see. Y batch stack new yt. So this is what we are going to do, and we are going to say torch.stack, and in the stack we are going to send new yt, which is having a dimension of 25 rows and 1 column, and we are going to send the y batches, which has the 10 rows and 1 column, and we are going to try and stack it. Let us see how the output looks. And you see immediately there is a error. So the stack expects each tensor to be of equal size, but got 25, 1 on entry 0 and 10, 1 on entry 1. So basically, if you're going to stack stuff, so the stack has to be of same number of rows. So for an example, if I'm going to stack two y batches, so two y batches will be having same number of rows, correct? Both will have 10 rows. So if I'm going to do this, so if I'm going to stack y batch 1 and y batches 2, then it will work. There's no issue. But if I do something else, y batch stack, let's say y batch 0 stack 1, so that looks not correct. So I'm going to say y batch 1 stack 0. That's better. And then I try to do y batch 1 stack 0, and I see the size, and I execute this. You'll see that it is able to stack it, and it has given me 2 batches of 10 rows and 1 column tensor. Let me show you how the y batch looks so that you guys can see what's happening. So here, this is the first batch, and this is the second batch, right? So now you are getting a feel of what stack can do and what concatenation can do. Concatenation does not need the rows to be same, but the stack needs the rows to be same. As you start practicing and playing with the datasets and try to push the datasets together and force it, you have to read the error. PyTorch has a wonderful error reporting capabilities. The errors are really very helpful. Unlike the other couple of various other libraries, the errors are usually cryptic, but in this case the errors are really informative, and you can exactly see what is the problem. So to that extent, PyTorch is awesome. Let's now move to the next step. So we have tried to work with a stack and cat with the data sets. The other thing that is available with Torch is that there are two classes. There is dataset classes and there is Dataloader classes. We have to discuss about that because you saw that most of the time we don't find tensors in the wild. We find NDArrays in the wild because NumPy has been around for a long time, and even recently I've heard that Python ships with NumPy by default. So with all these things, gathering momentum, NumPy is everywhere. But in order to convert from NumPy to Torch, you have to have a kind of an interface class which does the conversion for you and then provides the tensor as you require. So that is something we are going to explore in another couple of minutes. And after that, we will be exploring the embedding layer. Let us move to importing from torch.utils.data. So that is what we want. From torch.utils.data, import data set and data loader. So both we have to import. So just give me a second. So we have data loader and we have data set. So both we need to import. And the next what we are going to do is we are going to write a class by inheriting the dataset. So what exactly dataset has? So what elements you need? This is something that you guys have to have some background of object-oriented programming, especially with inheritance knowledge. Most of the time, most of the programs that you see in machine learning, neural networks, and any of the advanced AI-related libraries, they are going to involve classes. And most of the time, they are going to involve inheritance also, because the reason is very simple. This particular data set class has been written by the developers as a blueprint for other developers to write on top of it. So this might sound very cryptic, but if you have some basic knowledge of object-oriented programming, this will be a walk in the park. If you are new to object-oriented programming and if you are still struggling to visualize, there is a video that I am going to link in the description as well as in the link above. In the video, it will come up. Take a look at that. I have shown how you can think about object-oriented programming and visualize it, and what is the purpose of different ways of programming, like procedural, functional, and object-oriented. So that should give you some introduction into object-oriented programming in a different fashion. Let's now work on creating the class. So let us say class regression loader. So that is the data that we are going to regression set. So that is the data set that we are going to work with, and this particular class is going to inherit the data set class. And one of the reasons why we need the data set class is that data loader will take only data set class. It will not take any other object. And in order for the data loader to take the data set class, there has to be a couple of methods already available inside the data set class that you create. That's a mouthful, right? So let me continue with this definition, and you will understand what I'm trying to say. I'm going to create this class, excuse me, and I'm going to get the x data and the y data. So this x data and y data are going to be the NumPy array or ND array that we are going to work with, and we are going to say self.x data x tensor. So I'm going to convert it into tensor here itself. So I'm going to say x data dot from excuse me, I have to use torch here. So I have to say torch dot from NumPy and x data dot as type np dot float 32. And then I am going to copy this, and I am going to use the same for y data also. And yeah, y tensor, that is done. And the next thing that I'm going to do is I'm going to say self.samples n samples is equal to the self.x tensor dot shape, and I'm going to get the rows. So that's going to give me the number of samples, and all of these things I'm going to do it by initializing the regression set. So you'll see it in action in a couple of minutes. But apart from that, I need to do two more things. I need to give two more methods for this regression set class that I've created. So that is get item. So this will take self as well as an index, and this index is what we are going to concentrate on. So this index will return self dot extensor on the index, and it will also return self dot y tensor on the index. Basically, it will return the element that is present in that index, and we also need to have a length method also, dunder method, for data set to accept. So self, and this is going to return the number of elements or number of rows available. So that is going to return self dot n samples, and that is all. So this is the way you have to write the class for your particular modification. And once you are going to execute this, the class will be ready. But we have not called the class yet. So this is the blueprint of the class that we want. But next we need to instantiate an object. So instantiation is nothing but creating an instance of this new class that we created. So let us dive right into it. So I'm going to say a new, okay, let us say reg set. There's nothing new about it. I'm going to say regression. Once you do this, you will see that regression set class is coming up. And now here you can see that regression set is asking for X data and Y data. Apart from that, an abstract class representing class dataset. So here you can see that dataset is actually an abstract class. An abstract class is basically a blueprint, which has certain, you can read all about it here. All dataset that represents a map from keys to data sample should subclass it. All subclasses should override the method getItem that we did, and also it should override the method len. Both of these things we have to do it. That's what we have done. And now we are going to send in for X data. We are going to send in the X data that we have got from just a second. Okay, we can actually send the dummy data also. So dummy 01 has the X data 1, right? And we can send for Y data. We are going to send dummy 1. So this is 0 index is going to be the X data. Actually, if you see in the dummy data, let me actually show that to you after we complete this. Once we do that, the reg set has been completed, and we are going to do a index, and you see that it is returning 2 tensors. So this is the X tensor and this is the Y tensor. So it is working. And if you do a reg data loader, so you'll see I'm going to call data loader, and to that data loader I'm going to send the reg set. That is a data set that we instantiated. That's going to accept. But how are we going to use the reg data loader? So for actually working with the reg data loader, it's not simply we send it like this. We have to give more information to the reg data loader. So for that, do a shift tab here. You will see there are lots of information here. So there is batch size, there is shuffle, there is sampler, there is number of workers, there is the multiprocessor, the generator, and a lot more. So you can see that all out down here. What we need to do is we have to concentrate on the dataset, which is a dataset object, and we need to concentrate on the batch size. If you want, you can shuffle the data based on your requirement, but the output is going to be pretty interesting. So let me show you the batch size. So I'm going to let me change this to dataset, and I'm going to say reg set here. And for the batch size I'm going to say 5, and for shuffle I'm going to say true. Okay, so once I give this kind of the information to the data loader, do not select workers. The number of workers, if you select it, if you don't have CUDA cores, or if you don't have GPU, and if you select number of workers, then the data loader will fail. So do not select number of workers. That is. Once you've done this, we can actually iterate on the data loader. So what we can do is we can actually say for X, instead of actually iterating directly on the entire data loader, we can just iterate and get one data point out. So let's say data point is equal to, we are going to say next iter. So we are going to convert the data loader into iterator, and we are going to send the reg data loader into the iterator. Once I execute this, the data point is going to give me one batch of data. You see this? You have got one batch of data. So this is one batch of X data, and this is one batch of Y data. And you see something is wrong here. What is wrong here is that the Y data is not a column. So what mistake did we make? Let us roll back. We have made a mistake in this location. And I want you guys to take a look at this video and also the earlier steps that we made in this series of steps here, and think what would have gone wrong and how we can correct it, how we can get the batch of Y data in the same shape as that of, not the same shape, at least in the same format as that of the X data. So try to practice it, and try to see what you can find out and what you can learn. And in this video, we have learned a lot, in fact. So we have seen that we can work with the mass fill, we can work with the data loading from SKlearn datasets. We started working with cat and stack again. You can try to squeeze and unsqueeze. It's not going to be very useful when you're going to work with big data like what we did right now. And next, in the forthcoming videos, we can see how to work with the various layers. And we'll be working on embedding, flatten, linear, dropout, softmax, sequential, maybe a little bit of convolutional also, and other activation layers in the next video. Till the next video, stay tuned and enjoy exploring PyTorch in Raspberry Pi. Have a great time, guys.